Welcome back, and we're taking yet another look at the Godot engine. Welcome to an overview tutorial of the new Godot 3.0 engine. I'm so excited! It's got basically new color paint, some new stuff under the hood. It's great. I love it. Once again, in the description box below, you will find a zip file containing all of the projects we'll be looking at. You'll see a spaceship scene example there. I just threw that in there to sort of keep everything in one go, because you should also be looking at the scene tutorial that should be uploaded along with this general overview tutorial. In this specific case, we'll be looking at the Godot overview tutorial example incomplete. This is sort of the answer sheet, if you will. This is the version that we'll be modifying and looking over. I would like to point out, this is an overview tutorial. I am not going to be doing a deep dive into the GDScript. I'm just here to sort of introduce some of the ideas of Godot, get those, get the workflow of the engine into your head, and at a later point, I'll be doing a video specifically on GDScript, because it's a topic that not everyone who uses the engine really needs to know, because there are, of course, artists that may be collaborating with people who are using the Godot engine, and it's more important that they sort of understand what's happening as opposed to learning how to code. So in this case, I'm going to go ahead and remove this, because there may have been a botched attempt to record this at some point. So what I'm going to do here is, once you open the engine, if you've never run it before, you can go ahead and find the download link in the description below, or just look it up as well. You will want to import the project from the zip file. To do that, just click on import, hit browse, and go over to, and you will just path over to where you have the project downloaded. In my case, I just have it under my programming folder. Of course, under the projects, I'm relatively organized, I like to think. Go ahead and just click on the incomplete folder, which should be right here, and just click on project.godot. That is the file. Then, once you're ready, hit import and edit, and we'll be good to go. Hop right into it. And once again, we're going to have, the Win3 editor, because now the test scene is empty. Now the test scene is, so we're going to just mash everything together, and it's going to be awesome and stuff. We're going to have stuff flying all over the place. It'll be great. So the first thing that you want to do, at least when you start the game, is sort of decide what resolution you're going to be running it in, right? So this is now found under project settings, under project, a little bit down, kind of protected there, but in any case, what you want to do is you want to be in the general tab, and under display/window, just down here, you're going to set the resolution, or the size of the screen in pixels. We're going to pick 1366 by 768. The full screen and borderless window modifications are here. We're not going to do that though. We're going to stick with this here. There's a lot of options in here as well, but this is probably the most relevant one to you, as well as, of course, picking the main scene, which is already test scene. This is under application and run. Also config here if you want to rename things as well. And pick an icon for it as well. If you're compiling it to Windows, of course, you want to pick a spiffy little icon. So now what we're going to do here is we're going to define some of the controls for our player. Now, obviously, we're building this for a computer, so the way that you define controls in Godot is actually very simple. It's very intuitive, in fact. Once again, if you go back to project settings, or if you didn't close it like I did, you can actually just go over next to the general tab. There's called input map. Input maps are exactly like they sound if you've played the video game before. They're just input mappings. UI accept is enter, KP enter, keep, I'm not really sure what the KP is, but it's enter, it's space. And as you can see, I've already defined a couple for us here. Player1 P1 or player1 underscore up. And the reason why they have this specific naming scheme is that we can call them by their name later. So we can sort of, we can say if the player is pressing P1 up, meaning the key up, or I can even add another key. So let's say I wanted to use WASD as well. If they're pressing W, or I changed it, sorry, to add another key bind if I want to add. So I guess I'm going to go ahead and add back up. You would add a key press and press up. And done. So now if we're checking if the player is pressing P1 underscore up, then it would check if the player is pressing either W or up. I'm just going to get rid of the up one now, or the W one now. So what we're going to do is we're going to go ahead and define our own, and the way you do that is you just come up to the text box that's up here, and just type in the name of whatever you want your input map to be. In our case, we're going to use p1 underscore shoot and p1 underscore jump. You may bind these to whatever you like. As I mentioned before, you can click on it to rename it. I'm going to go ahead and click the plus here, add a key bind, and I think we'll go ahead and use F here. This will be a little bit weird, but and if we jump, I think spacebar is pretty traditional. Go ahead and use spacebar. Okay, so as you can see, we've created the key bindings. By the way, all the UI key bindings are already pre-made for you, but we have the key bindings P1 up, P1 down, P1 left, etc., etc. And that's all we're going to do there. So if you want to make your own input mapping for maybe player 2, then you will also do that in here as well. You can also do that in the code, but this is, I think, a little bit more simpler. So with that out of the way, if you go ahead and look over here to the left to our file structure, go ahead and double click on the player folder and then double click on the reticle folder. And we're going to go ahead and open up the aiming reticle scene. Now in the aiming reticle scene here, what I have set up here is a node 2D with a sprite node as the child. In the sprite node, we have a texture mapped to it, and is the targeting reticle PNG that you see over here. Attached to it is our very first look at a script. Now, what does a script do? Well, as you can imagine, it's a piece of code. Go ahead and click on the script icon, and you'll jump to the script editor here in the top. And here we are. Now, I would like to point out a couple of things here. First, if you've never worked on a game before, the origin of the screen, or have never used GUI in any other programming language before, the origin of the screen is actually in the top left. If you're wondering why, this is because CRTs back in the day would start scan lines from the top left. So this is 0, 0. What that means is if you want to move to the right, you actually have to add to the X value, which is normal, and you have to subtract to the X to go left, right? However, to go up, you actually add to the Y value, and to go down, you subtract from it. So that axis is inverted. Keep that in mind if you're bug fixing things for movement. So this might seem a little bit overwhelming, but I'm just going to break it down into its basic parts. The first thing here is the ready function. What the ready function does is, again, I've tried to make sure this document is very well commented so that if you're just looking at it, you'll be able to sort of understand what everything does here. Well, whenever you create the object, this is called. So you're noticing that I'm sort of setting the z index here to 1. And the z index is actually the depth at which an object is drawn. A higher number means it's drawn closer to the screen. So to make sure that our reticle appears above everything else, I've given it a value of 1. Set input goes ahead and sets an input array. However, what I'm going to do is I'm going to go ahead and break this down to something a little bit more simpler for you guys. And then set process true sets the process function to run. This is important because what the process function does is it's called every frame, with the delta being the difference in time between every frame. You'll then notice that I've created my own method here called simplified move. Now the process and ready functions of Godot are inherent and are always and essentially a part of the scripting language itself. Simplified move is something I've made and added myself here. So what I'm going to do here is I'm going to break this down a little bit more simpler for you guys. I'm going to go ahead and delete all of that. And the first thing that we're going to do here is we're going to make an if statement. If you've now, I'm presuming that a couple of the people watching have already done a little bit of programming, but in any case, so as you would know, you would start with an if statement, meaning if this is true, do the next following line. So the way it's done in Godot is you do if. You don't have to put a parentheses here, but I'm going to go ahead and do that. Is first. So now we're going to check if the input map is being pressed. We would say if input dot is action pressed. As you can see, it's sort of already completing the method here. And I would like to also mention that down in the description box below is a link to the API. So if you're curious about learning it on your own or exploring some of the methods that are already available to you, you may go ahead and do that. So I'm going to say input dot is action pressed, and then we're going to use let's start with player 1 up. Whoops. Make sure this is a string, by the way, and to denote a string you use the quotation marks there. So it's already filling out our input maps, and I'm going to go ahead and do P1 up. Then you end it, because this is based on Python, you want to end it with a semicolon. So now we're going to try and move our object up. How do we do that? Well, if you remember from what I just mentioned about the grid, we're going to first edit the position variable. This is different than Godot 2.1, which had you use set position, but instead it is now an instance variable, so you just say position.y, as in we're changing the y position, the y value of the position. Specifically, it is a vector, but again, I'm trying to be a little bit light on the terms, so position.y will change the y value. And now we're going to, I'm not going to shorthand it for this one. We're going to say equals, and we're going to say equals position y minus, and then you'll see that I already have a variable defined here for how much our reticle should move when we press the key. So I'm going to go ahead and use that variable, minus move speed. And that's what that does. So what it does is it takes the current position of our object, which is, let's say, 0, 0. It subtracts 20 and sets it to position y. So now our new position in the y-axis is -20. The next frame, it does the same thing. -20 minus 20 is -40, and now our position is now -40. And assuming this is, of course, the player is pressing up. We're going to do a similar thing if the user is pressing down. Just going to type this out here because it's more or less the same thing. However, the major difference, of course, being we're going to add the move speed this time. Now we're going to do a very similar thing for the x-axis. So we're going to do left, of course, and then this needs to change the x. Now I'm going to go ahead and shorthand this, and this is a bit of a carryover going left, so I'm going to subtract here. A little bit of a carryover from other languages where you can sort of shorthand it. So position y plus move speed here. What the minus equals means is essentially this. Position.x minus. Oh, well, I used the wrong variable there. My bad. This should be move speed. Sorry. But what? There we go. What this expression means with the minus equals here is this. It's the exact same thing. However, this is just shorter. And then we're going to do the exact same thing for right. Just like that, except obviously we're adding this time. So that is our simplified move, and when we go ahead and run it here in a second, you will see that it works as I explained it to. What you'll see down here, though, is a much shorter method that does actually the exact same thing using this array up here. You may look at this on your own. I'm just letting you know that this is an option that you can do given the way that Godot does things. It's actually very, I think it's very efficient and interesting. But in any case, if you remember from the spaceship example, you should remember that, first of all, the aiming reticle is its own scene. And now what we're going to do is we're going to go to our quote-unquote level, and we're going to add the reticle to our scene. It's under player, reticle scene. And there it is. Now when we hit run, and again, if you go into project settings, the main scene is set to the test scene. Oopsie daisy. Oh, fascinating. Whoops. I accidentally left the script attached to the test scene when I compiled everything for this example. In this particular instance, I would ask you, whoops daisy, my bad. Go ahead and right click on the test scene. There's a script here. We actually want to remove it for now. Just hit clear script there and then hit run again. That wasn't supposed to be there at the beginning of it. But in any case, once you do that, you will find that the reticle is in the top right, as you can see in the scene here. This blue bounding box is what indicates the viewport of the screen. Every scene in Godot has a viewport as a parent. I should have mentioned that, but it's not too important without getting too technical. And again, if we press the arrow keys, you can see the reticle is moving. If I press up, it goes up, down, it goes down, left, it goes left, right, it goes right. But you can see it's sort of not contained within the borders. And at the end of the tutorial, I'm going to sort of ask you to sort of figure out how to do that on your own. So that's that. That's the aiming medical. However, this isn't really a first-person game, so maybe let's add a character, or at least I wasn't trying to make a first-person game, so we're going to go ahead and add a character. Specifically, we're going to be adding the player now. Okay, so now we're going to backtrack up here to the player folder, and we're going to be adding a rabbit to the scene. Now, the rabbit I would like to mention was drawn up by the partner I had for this project last year, Aaron. So thank you very much to Aaron. We can see her last name, obviously. And the way that we're going to do this first is I'm going to introduce animated sprites. Now, animated sprites, as you can imagine, are going to be the basis of how you make a 2D game in Godot. And it has, of course, it comes with several animations. Again, if you were to make this from a blank sheet, from a new scene, if you just construct a new scene, you would go ahead and hit plus, and then you would just type in animated sprite. There it is. But we're not going to do that because I already have it set up here. So you have the animated sprite. And what we're going to do here is you're going to add, we're going to click on the frames here. I'm going to backtrack a little bit because I think I went a little bit too fast. You're going to create a new frames, which is what you do. You would say make a new sprite frames. And then you're going to hit edit. So now that I've gone and edited here, you can see that I've already sort of dragged in the default idle animation, but now we're going to add jumping to this character. So to create a new animation, go ahead and click on the new page icon over here. Click on a new anim to rename it, and we're going to be renaming it jumping. If you go over here to the jump folder, you can see that I already sort of have our sprites set up here. Go ahead and hold down the control key and click on 000 and 001 so that we can select both of them at the same time. That's where you're holding down control, and then just drag both of them in. And there you go. The second animation we're going to make is just called jump rising. Jumping underscore rising, just like that. And then this one. And then you're going to add 002. There we go. And then the last one we're going to add is the move, of course. So just call that one move. And then grab the move left. And I believe it's shift click. Yeah, hold down shift and click on the first and then the last one and drag all of them in. There we go, it's that simple. So if you have an artist, it's that easy. Just go ahead and drag all the files in. Now, for the speed in frames per second, I'm just going to set this to 8. Again, this is completely arbitrary. You would decide this on your own, of course. Keep loop on here. For the jumping one, 12, because we want that to feel a little bit faster. So now that is out of the way, the next thing that we're going to need to do is, because the player is going to be because the character is a kinematic body 2D, which as you can see here is a physics object, we want to give it a collision box so it can interact with other physics objects. Now I'm not going to go super in depth into the physics engine of Godot, but I can mention that there are 4 basic types of physics-enabled objects: the kinematic body, the rigid body, the area 2D, which isn't technically physics-enabled, but it is part of it. It's part of collision, and as I'm now blanking on it because I went off on the area 2D tangent, it is the oh dear, where is it? Here we go. Kinematic, static. Static was the other one. Static bodies are meant to be platforms. Rigid bodies are anything that you would imagine as like a quote-unquote physics object, like a bouncing ball, for instance. And the kinematic body 2D is meant to be, say, a bullet or a character, something that's more so controlled by the player, or something that you want to move on your own independently of the engine's physics. And the area 2D is sort of just like a 2D area for detection and 2D physics influence. So there you go. The other one, good descriptions here. So we're going to add a collision box to it. And the way you would do that is you would not add a script. You would go here and click the plus icon as I just did, and just type in collision. Again, make sure you're using the 2D objects, not the red ones. Looking for the blues. And you want to click on collision shape 2D. Then Once you have that here, it says null here. I'm just going to go ahead and pick a shape here. I actually forget what I used last time. I think I'm just going to go with the rectangle because the rectangle is probably the simplest. Click on again, hit edit, and then we're just going to edit the size here to match our little bunny, or rabbit as it were. And yes, I'm just putting in numbers here until I get one that fits. Oh, that's pretty good. There you go. 8200 works. Now if you want to change its position, by the way, and again remember, because it is it is relative to the kinematic body here. If I move the kinematic body, whoops daisy. Well, actually, I grab the I can't really help but grab the collision box because this is on top. But what I do if I move the collision box and then move the sprite and then move the player kinematic body, which is this right in the middle of them, they both move with it because again it is all relative. So I'm just gonna hit the Control Z to undo all of that. So now we have a collision shape 2D attached to it with it has obviously a hitbox. Let's explore the code a little bit. Now I've gone ahead and left these two blank here because now we're going to go ahead and fill in our shoot. This is where we put our player 1 shoot that we defined earlier, as well as our player 1 jump key. So those should be F and space unless you define them to whatever you wanted. Now again, I wanted to remain as light on the code as possible because this isn't really meant to teach you how to program in GDScript because that will be its own tutorial. This is meant to be an overview. And I'm just going to more or less go over a couple of the methods here. In process, I use a method called move and slide. Move and slide is very specific to kinematic body 2D. And this is so that, as I mentioned before, kinematic body 2Ds can be moved manually in code, which is actually what we do here to move horizontally. As you can see, I sort of have a similar thing to the reticle where I sort of just move the X and Y left and right. However, when you do this, it is not interacting with physics bodies, so it will not have collision. So, which is why you want to move and slide, because it will interact with physics bodies when you use this method specifically. The input event is something I didn't use for the reticle. In fact, I did this again. I did input dot. The reason why you would want to use the input event is, well, at least in the previous version of Godot 2.1, is where you would use it to check for inputs called once, although it is a little bit more convenient because the input event is only called whenever input is detected. So you'll notice here that for specifically the jump, where we have our jump input variable, if I go back to the top here, we set that to P1 jump. You'll notice that I'm essentially checking if the number of times that the player has jumped is less than the maximum number of times they can jump. And yes, obviously you can jump. You can set that to whatever you want. You may feel free to play with this after, or maybe now if you want. Always pause the video. Event is action pressed, and you want to use event dot in the input event is action pressed jump input, and it will have that code here. And then of course we use set animation to set the animation to the jumping. But the last thing that I did want to mention, of course, is the animation finished, although that is a signal. And we'll get to signals a little bit later, but essentially it's just whenever the jumping animation is finished, we go to the rising animation. All right, go ahead and hit Control S to save the script along with the rest of the player scene. Go back to the 2D editor. Go to test. Whoopsie daisy, not that one. You're going to hit this one so we can instance our player rabbit. Hit back to go back a level in the folder structure, by the way. Rabbit, player scene, oopsie daisy. Click on make sure you clicked on this one so it knows that you're trying to add the player scene as a child of test. Click on that. Just plop that in the scene. By the way, you actually don't need this anymore because I make my if you look at the player script again, I actually demonstrate how to create a new instance of the reticle. This is a little bit convoluted, so you can actually really just go ahead and copy and paste this specific code if you want to construct another, if you want to instance another thing in code. That's how you would do it. But in any case, go back to the editor, hit play, and then we'll fall right through the floor. Hopefully. Yep, there it is. We fell right through the floor. Now, why did we do that? Because remember what I said. Obviously, we have a bit of a gravity system in the player object. Now, kinematic bodies, again, you sort of have to move them a little bit more manually. But I think they're much better for platformers. So actually, have an artificial gravity system here again. Again, if you don't want to make your own, you can go ahead and just copy mine. no problems with that at all. But obviously we need a platform now. And how do we make a platform? Well, first of all, you want to make a new scene, right, guys? Hello? Okay. So I have a wall scene here. It's as basic as it gets. It is, as you can see, it's just a static by 2D. Again, mostly platforms are static because they aren't moving. So, but they interact with physics or other physics objects. So you want to make this. I gave it a collision shape 2D, and I gave it a green box as a sprite because I'm not an artist. Again, the rabbit was done by my previous partner, Aaron. So, what are we going to do? We're going to add the wall to the scene. I'm going to back up here. Environment, wall scene. Boom. Here's our platform. Just put it right in the rabbit. Play. Done and done. You know, you can wipe your hands off, do whatever. You're done. Woo, there it is. And if we hit spacebar, there's a little jumping animation. And I think if we hit F, it might actually crash because we haven't gotten to the carrot scene yet. But in any case, that's that. Now, what if you want to make this bigger? Boom. Done. It's bigger. Now, there is something called tile sets, by the way, if you want to make a sort of like a Mario level block kind of thing. If you want to do a block construction, you would use tile set. But again, it's another tutorial. In this case, you can just stretch this out. Also, if you just had if you had set platform sizes, maybe you could have a separate sprite for just how long they were. But again, tile sets would probably help here to do that. But as you can see, even if we stretch it out, again, because it's all relative to the parent, and I'm stretching out the parent object. Oh, okay, carrots do work. Okay, never mind. As you can see here, the hitbox has also been stretched out as well. If I just walk over here, I'll just fall through. Because the hitbox just fell off here, over here. Okay. But in any case, so also as well, if you wanted to make a wall so the player couldn't fall off the edge, you would do this, whoop, and then you would make it invisible. You would go ahead and just hit this toggle visibility. Oops, a little bit too far out there. Because I don't believe that I have the hitboxes of the sprite to be one-to-one here. Oops, and it's still visible because I needed to see it to move it. That's it's generally pretty important to do. There we go. I can't turn off anymore. But yes, I zoom in here in the collision shape. It's a little bit off, so that's my bad. Again, I'm not really the best artist at all, so which is why we're dealing with these green boxes here. And you just sort of up on the left side to keep the rabbit from moving there. Assuming you didn't want it to move off screen. I mean, that's up to you. All right, so let's give a little guy something to shoot at here. Something for him to practice for a little bit of target practice. Go ahead and click on the dummy folder and click on the dummy scene. Sorry if there's a little bit of cut there. Something came up. So what we're going to deal with now is we're going to, of course, put the dummy in the scene in a second. But I do want to explain something that I might have alluded at before, which is signals. Now, what's a good way to put this? Signals are signals. What they do is this sort of broadcast, and what you can do with a signal is once you receive that broadcast, you can do something with it. In this particular instance, or in the previous, oh yes, I did. In the bunny example, we saw that whenever the jump animation played, and I'm actually going to just run the scene so I can show this to you. Whenever he goes into that crouch, the animation switches over to the jump rising. It's face right there because he's stuck in the jump rising. Now, another way that I could have done that is actually just left the jumping frame as the last frame and just set it to not loop. But I wanted to demonstrate how that worked. In the dummy example, the way that works, or the way that you would connect it, here is actually, let me just disconnect it so I can show this to you, is the similar thing happens here with the dummy animated sprite. So if I go ahead and edit the frames from the animated frames node of the dummy, hit edit here, you'll see that I have an animation for it dying here. So what I want to do is at the end of it dying, I want to remove it from the scene. So the way I would do that is I would go ahead and click on the inspector and click on node here, where you see signals, animated sprite. So these are all the other signals it inherits. We're going to use animation finished. double click on it, and then click on the signal, or click on the object in the scene tree that you want the signal to broadcast to. In this case, we're going to broadcast to the dummy, because that's where the script is. If we go back to the other, just click on the script. You'll now see that I already have the function here, but it will give you the function, and you'll just sort of define whatever you want here. So now what I say is, well, if the animation is it dying, emit a signal defeated. So this is my own signal that I've created to send to other objects, and what this does is it sends this signal, and then queue free. Queue free is essentially the instance underscore destroy of this of the Godot engine, and that is how you would eliminate an object. You'll also see that I also use signals for Area 2D. The other thing that I did want to mention is this thing called groups. Now, groups are more or less how you're going to more easily identify. Is how you're going to more easily identify objects as what group they're in. In the carrots case, the group it's in is, if you it should open the inspector. You go to node here. It's in the friendly and projectile group. So you'll notice in the dummy script, I say if the area that we're overlapping with is, because you can see the method is called area entered, so the area 2D will check if an area has entered itself. If the area is a projectile and it's friendly, meaning it's friendly to the player, not the dummy, he loses health. So what we're going to do is we're going to make sure that the carrot also knows that the dummy is not a nice person. So again, we're going to add a group here. In the group, we're adding specifically is enemy. Who would have thought, right? And we're also going to add it to the area. Now, groups are not inherited, so you do need to specify, be specific about which object you're putting in what group. So, that said, if we add the dummy to our test scene, oops, I did it again. That was, I guess it was a reference to a song, but I didn't mean to do it in any case. Add it to the scene, put it wherever you want, and shoot it. Its health goes down, shoot it again, its health goes down, shoot it again, its health goes down, the animation plays, and as soon as it's finished, it's gone. So now we have sort of the basics of a game here, and the next thing that we're going to do is we're going to introduce the a scoring system, right? Every game needs a scoreboard. Want to show off how good you are. So we're going to go over to the GUI here, and we're going to look at the score scene. Now, the score scene is a label, and all it does is it's literally just a label. It's just text floating. And as you can see from the code here, all it does is it has a single method in it called update score, which updates the score and then sets the text of the label to, oops, sorry, I'm gonna go over here, and sets the text of the label to score and then the score value. Now, since I just call set text here because the object itself has the set text method, again, the API is linked down below if you want to explore specific nodes and their own specific methods. Let's go back to the 2D editor in our test scene and add the score now to the scene. It's here. I'm not lost. And I did it again. There we go. There's our score scene. I'm going to move that over a little bit, and the way you do that is inspector. You can go ahead. Obviously, you can also just drag it to a position, but I'm a little bit more precise than that. I'm going to plop it like, I don't know. There, that's good. You hit play. And I believe I actually didn't do these signals properly yet. Yes, I did. So you'll notice that the score didn't increment at all, and we actually didn't get anything to happen, and that's because now we can give this individual level its own script. And now we're going to do that. We're actually just going to hit the new script. Oops, let me back up here. We're going to hit the new script icon in the top right, and then we're going to path over to wherever the test script is, and there it is. I think it already did it for us. So we're going to hit load, and then we'll just load the pre-existing script. But of course, you can also just make your own. Now we're going to pass on the timer here for a quick second because I'm going to focus on the scoreboard. So I'm just going to comment that out. Use pass because everything is expected to have a indented block next to it. Excuse me. So essentially, what we're going to do here is that we're going to connect the defeated signal. If you remember, we did that a while ago, the defeated signal. We're going to connect this to the test node, the level itself. And what happens is when the dummy is defeated, the score is updated by 1, and then we spawn a new dummy, which is this script right here, which is just, as I said, just makes another dummy. Then what it does is it connects the signal again, so we'll sort of loop over itself, and when another dummy is defeated, we'll spawn another dummy. So it should loop. Just shoot 3 times, and there's a new dummy. As you can see, the score has been updated. The power of signals, my friends. Now, I believe now, yep, we're going to go ahead and add the timer now. We go over to the timer scene again in the GUI here. Our display timer. This one is an O2D, and it contains a label and a timer node. Now, a timer node is a timer. You set a wait time. The one-shot variable here, if I actually hover over it, it should just tell me, or it should tell you. That's not what I was looking for. I think click on it. There it is. Essentially, excuse me. What it does is essentially a one-shot means that it will only run this is not checked. It will loop continuously, repeating, saying the signal in that case every 1 second. And again, this is also something that you can change, by the way, when referencing a node. Again, not a GDScript tutorial, sorry, we'll do that later. So, essentially what this does here is it sets up the timer, it has a set timer method, and then it emits a signal times up. Should be pretty straightforward here. Boop. Go ahead and add our timer. Just leave it there, hit play, and I commented out the part of the test script that sets the time. My bad. So now the way that you reference a specific object is that you can say, in this case I say get node display timer, and what this does is within the test scene, because the script is within test, it gets the node display timer, and you can really and you easily access child nodes. So whoopsie daisy, sorry, I clicked on it. Go back to script. So I access the display timer node, and then I call from the display timer node the method set timer. And if we go back to our display timer script here, there is that method with that code. So it essentially calls it for us with the time 60 and sets the time to 60 seconds. If you need to access the parent, by the way, you say get underscore parent. I actually say it right here. And that's how that would work. So now we hit play. And here we go. We have a semi-functioning game, right? You know, everything's relatively complete. We have a score system. We have a time limit. Although I think that there's actually like a best case scenario right here. And then it's blank, because this is more or less where the tutorial overview sort of ends. Now, obviously, we're sort of missing a large chunk of it, because a large chunk of it is code. The philosophy of the Godot engine, from what I heard from the docs anyway, don't quote me on this as a Godot developer, because I'm definitely not one. But I believe that their stance on it is essentially that a drag and drop system isn't as hands-on, and it's always going to be limited, which is why they encourage people to learn how to code, because I think coding is a relatively important skill for learning how to make games. This tutorial, again, is meant to focus on an overview of the engine's function itself. GDScript tutorial will come later, where I'll take a much deeper dive into how to code in GDScript. So that will come later, but hopefully I've sort of given you an idea of what you can do here. And once you've maybe done the GDScript tutorial, or you've sort of feeling a little bit ambitious, you can sort of play around with these values yourself and see what changes. Again, I would like to link you to the Godot API in the description box below if you're interested in learning more about it. So hopefully this was an adequate overview. I really just wanted to get something into your guys' hands that you can sort of play with. So now you have you have a relative setup here for what could be a fun little game if you want to expand on it a little bit more. I technically already have. In fact, this is sort of based on the Reese's Rabbit Rumble game that I made quite a while back, but now you have the tools to make something similar. As well, you also have, of course, the tools for making something a little bit more RPG-esque, right? Because you already know how to do four-dimensional movement. You could easily turn this into a top-down perspective if the reticle was the character and things shot up from the reticle instead, as opposed to using it as an aiming tool. You have some options for a side scroller, as I sort of just demonstrated. I sort of just demonstrated with this. Hopefully, you'll find your collision boxes a little bit better than I did. You have the tools to make signals. You've learned how to make signals, how to connect them. You've hopefully discovered something new here and learned something about the engine. Hopefully, that was the goal. So thank you all for watching. Hopefully this was helpful. Look out for some of the other tutorials if you're interested in taking more. If you're interested in learning a little bit more about the engine, including how to program in GDScript, as well as use OpenVR, because I will be doing a VR tutorial as well. Be on the lookout for that. Thank you all for watching. Hope you all have a wonderful day.